Let's be real, the world is suddenly speaking this whole new language, right? You're hearing about machine learning, deep learning, LLMs, and it can feel like a lot. But what if I told you all these complex terms are just layers of one single, pretty simple idea? Today, we're going to peel back those layers one by one and build a really clear map of the world of AI. You know, this quote right here is the perfect place to start because it's a huge aha moment for so many people. It's super easy to think of AI as just one thing, like a product. But the truth is, it's this vast field of study, just like biology or physics. And once you really get that, everything else starts to click into place. So the big question is, how do all these buzzwords, machine learning, deep learning, generative AI, how do they all fit together? Well, the key, and this is the most important part, is to see them as nested layers. Let's build that mental map right now. Okay, the absolute best way to picture this is with a set of Russian dolls. The biggest outermost doll, that's artificial intelligence, the entire field. You open that up and inside, you find the next doll, machine learning. Pop that one open and you get to an even smaller one, deep learning. And then right at the very heart of it all, you find the technologies we're all using every day, generative AI and large language models. So let's open up that first layer. This brings us to machine learning. And this is where the magic really starts to happen. At its heart, it's all about creating programs that can teach themselves and get better just by looking at data, without a human having to sit there and code every single possible outcome. So here's the basic idea. You feed a program a ton of data, let's say years and years of sales numbers. The program trains a model by hunting for patterns in all that info. Then, and this is the cool part, you can show that model brand new data it's never seen before, and it can make a really smart prediction. That right there is the core of machine learning. Now, machine learning basically comes in two main flavors. First up, you've got supervised learning. This is where your data is all nice and tidy with labels. The model learns from those labels, like whether a food order was for pickup or delivery, to make predictions. But then you have unsupervised learning, where the data is just a big, unlabeled mess. The model's job is to dive in and find hidden patterns all on its own, like finding natural clusters of employees without being told what to look for. And here's the crucial difference. It all comes down to a feedback loop. A supervised model makes a guess, checks it against the right answer in the labeled data, and then adjusts itself to do better next time. It's always trying to close the gap between its prediction and reality. Unsupervised models, they don't have a right answer to check against. They're just explorers out there finding interesting patterns. All right, let's go to our next doll. We're diving one layer deeper into deep learning. And this is where things get way more powerful because we start taking inspiration from the most complex thing we know, our own brains. So what is deep learning? Well, it's really just a specific, way more advanced kind of machine learning. And its secret weapon is something called an artificial neural network. Now, you don't need to be a neuroscientist to get this. Just picture a computer model that's loosely inspired by that incredible web of neurons firing away in our brains. And why do they call it deep learning? Honestly, it's pretty literal. It's because these neural networks have multiple layers of these artificial neurons stacked on top of each other. The more layers you add, the deeper the network gets, and the more complex the patterns it can learn. Basically, more layers equals more brain power for the AI. This extra power leads to some seriously amazing stuff. Let's take bank fraud detection. A big bank has an unbelievable amount of transaction data. We're talking billions of data points. There's no way they can have people label every single one. Maybe they can only manage to label a tiny sliver, like 5%, as either fraud or not fraud. This is where deep learning is a total game changer, using a technique called semi-supervised learning. Here's how it works. The model first studies that small 5% chunk of labeled data to learn what fraud looks like. Then, it takes what it learned and applies it to that massive 95% pile of unlabeled data. It essentially teaches itself using the whole data set, which lets it make incredibly smart and accurate predictions on new transactions. Okay, so now that we're inside the world of deep learning, we come to a major fork in the road. Generally, these powerful models are designed to do one of two very different things. Either they classify what they see, or they create something brand new. First, you've got discriminative models. Think of these as the sorters. Their entire job is to discriminate or classify data. You show it thousands of pictures labeled cat and dog, and it learns the difference. Then you show it a new picture, and it gives you a simple output, a label. That's a dog. It's all about putting things into the right buckets. But then, on the complete other side of the coin, you have generative models. These are the creators. They don't just sort information, they learn the deep down patterns in the data and then use that understanding to generate something totally new. So instead of just telling you a picture is a dog, a generative model could create an image of a dog that has never, ever existed before. And that is a massive leap forward. So here's a really simple rule of thumb for you, a little litmus test. If an AI's output is just a category, like spam or not spam, or maybe just a number or a probability, it's not generative AI. But if the output is something brand new, fresh text, a song, a unique image, then yeah, you're definitely looking at generative AI.
And that finally brings us to the very center of our Russian doll, large language models, or LLMs. These are the powerful engines that are running behind the scenes of all the chatbots and AI tools that we're all getting so familiar with.
So what's the deal here? LLMs are a type of deep learning, for sure. And they're often what powers generative AI. But, and this is important, they are not the exact same thing. A good way to think about it is that the LLM is the specialized brain, and generative AI is one of the amazing things that brain can do.
Now, this dog analogy is just a perfect way to understand how these LLMs are built. First, a model gets pre-trained on a ridiculously huge general data set. Think of it as reading a giant chunk of the internet. This makes it like a generalist pet dog. It's smart and knows all the basic commands like sit and stay. But then it can be fine-tuned on a very specific, smaller data set, and that's like taking the family dog and giving it intense, specialized training to become a police dog or a guide dog for a very complex job. So it's really a two-step process. That first step, pre-training on massive data sets, gives the LLM its broad skills, like summarizing an article or answering general questions. But it's that second step, fine-tuning, that creates a true expert. You can fine-tune a model on nothing but medical journals to help doctors with diagnoses, or on financial reports to spot market trends. And what's so cool about this is the business ecosystem it creates. You have these huge tech companies investing billions to build the incredibly powerful general-purpose pre-trained models. Then, smaller organizations like a hospital or a local bank can take that base model and fine-tune it with their own private specialized data. They get a custom, expert AI tool without having to build the whole thing from scratch. It's a total win-win. So let's just quickly recap the whole journey through our Russian dolls. We started with the biggest doll, the entire field of artificial intelligence. Inside that, we found machine learning, where programs learn from data. Go deeper, and you hit deep learning, which uses those brain-inspired neural networks. And right there at the core, we found the powerful tools we use today, like generative AI and LLMs, that can actually create new things and understand our language. So, we've unpacked all these layers of AI as they exist today, with each one building on the last to get more and more powerful. And that really leaves us with a fascinating question to chew on. As this technology just keeps accelerating, what's the next doll in the set going to look like? What new capabilities are waiting to be unlocked in that next layer?